Hi and welcome. In this video, we introduce another family of the functions, namely the family of radical functions. The parent function for the family of radical functions is y is equal to r of x equals to positive square root of x. Because of the square root, the domain of this function starts from 0 and runs up to plus infinity. That is, the domain is not including negative numbers. To study the behavior of this parent function, let's sketch its graph. For that, we consider the two-dimensional space and give some values to x from its domain and find the square root of those values. Square root of 0 is 0. If x is 1, square root of 1 is 1. If x is 4, positive square root of 4 is 2. If x is 9, square root is 3. Putting these values on the xy coordinates, this is 0 and 0, 1 and 1, 2 and 4, and 9 and 3. Connecting the points, we get the graph of y is equal to r of x, which is the square root of x. As you can see here, the range of this function is also starting from 0 and runs up to plus infinity. This function is 0 when x is 0, otherwise it's positive for all positive values of x. The function is increasing for all values of x in the domain, and the x and y intercept of the graph, as we can see, is the origin. We can apply a number of transformations to this parent function. For instance, if we want to shift it by a units to the right, we get the square root of x minus a. If we shift it to the left, we get the square root of x plus a, with a being positive. If we want to shift it upwards, we get square root of x plus b. And if we want to shift it downwards, we get the square root of x minus b, with b being positive. And if we want to shrink, we multiply c with the square root of x, with c bigger than 1. And if we want to expand, we multiply d with x, where d is less than 1 and bigger than 0. For example, consider the parent function square root of x shifted to the right by 3 units and upwards by 4 units. That is r of x minus 3. This minus 3 is for the shift to the right, and this plus 4 is for shift upwards. That is 4 plus square root of x minus 3. Or shrink the function by factor 4, shift it to the left by 5 units, and downwards by 10 units. As a result, we get, for shrinking, 4 times r of x, which is 4 square root of x. Let's call this function m of x. Then shift it to the left by 5 units and downwards by 10 units. We get minus 10 plus 4 times x plus 5, which is n of x. Now we consider n of x, which is this transformed function, and find its y reflection. The y reflection is achieved by replacing x with minus x. As a result, the y reflection is minus 10 plus 4 square root of minus x plus 5, which we denote by p of x. The general form of a radical function is k plus square root of ax plus b. We can show that y is equal to f of x is a child function for the parent function y is equal to square root of x. To do that, what we do is we take a as a common factor, x plus b over a. Then we take the square root of a, denoted by d. Then we take the square root of a, denoted by d. What remains under the radical sign is x plus b over a. As a result, we have k units upwards or downwards shift, depending on whether k is negative or positive. B over A units left or right shift, depending whether B over A is positive or negative. And D units shrink or expansion, depending whether D is bigger than 1 or less than 1, bigger than 0. For instance, consider y is equal to minus 3 plus 9x minus 20 and write all transformations. We start with taking 9 as a common factor, x minus 20 over 9. Square root of 9 is 3, we move it outside. As a result, we get minus 3 plus 3 times x minus 2.2. Hence, we have downward shifts by 3 units, right shift by 2.2 units, shrink by factor 3. Furthermore, consider g of x, which is minus 10 minus 4x plus 20, and write all transformations. We start off by taking 4 as a common factor inside, which results in x plus 12 divided by 4 is 3. Square root of 4 is 2, inside remains x plus 1. Then we take minus 1 as a common factor outside. Why we do that? The reason for that is that we want this shrink factor to be positive. Taking this minus outside, we have minus 10 plus 2 times square root of x plus 3. Hence, we have 10 units downward shift inside here, 3 units left shift because of this plus 3 here. The shrink factor is 2 units. And finally, because of this minus sign outside, we have a x reflection. Next, consider y is equal to h of x, which is minus 2 minus square root of minus 16x minus 4. And write all transformations. As always, we start with taking 16 as a common factor. Inside we get minus x minus 1 over 4. The square root of 16 is 4, which we take outside. Inside we have minus x minus 0.25. Then we take minus 1 as a common factor. We get 2 plus 4 times square root of minus 6 minus 0.25. Hence we have 2 units upwards shift because of this 2, 0.25 units shift to the right because of this minus 0.25 here. The shrink factor is 4 units and we have O reflection. Why? Because first of all we have the y reflection here because x is being changed to minus x, and because of this negative sign outside we have also an x reflection, that is the x reflection of y reflection, which gives us the O reflection. Next, consider the function y is equal to n of x minus 10 plus 4 times the square root of x plus 5, sketches the graph and specifies domain and range. We start with the parent function y is equal to square root of x, shrink it by 4 units. If we shrink it by 4 units, we get this new function, which is 4 times r of x. Then we shift it 5 units to the left. As a result, we get 4 times r of x plus 5. Then move it 10 units downwards in order to get the graph of n of x. This last graph here is the graph of y is equal to minus 10 plus 4 times r of x plus 5, which is nothing but n of x here. Based on the graph, we see that the domain of this function starts from minus 5 and runs up to plus infinity, which is here, minus 5 up to plus infinity. And the range starts from minus 10, somewhere here, and runs up to plus infinity. Next, consider the function y is equal to m of x and write all transformations here. Taking minus 1 as a common factor, we get minus 2 plus 3 times square root of x minus 5. This minus outside indicates that we have an x reflection. Inside we have the shrink factor of 3, right hand side shift of 5 units, and downward shift of 2 units. Furthermore, consider the function n of x, 4x minus 16 plus 2, and write all transformations. Taking 4 as a common factor, we get that 2 plus square root of 4 times square root of x minus 4. One step ahead, 2 plus 2 times square root of x minus 4. As a result, the shrink factor is 2. Right shift is 4 units. And upward shift is 2 units. Practice for you. In the following functions, write all transformations, sketch the graph, and specify the domain and range. Y is equal to f of x minus 3 plus square root of 9x minus 18, 2. Y is equal to gx, 2 minus 3 times square root of 16 plus 4. Thanks for watching and good learning.